Okay, hello everyone. Good evening. Can you hear me? Okay, thank you. Okay, so we'll start. Basically, today is our last day for seventh number class. Not only for that, anyone have any problem regarding any topic on this online training program, or further, if you need any support regarding this online training program, you can simply contact. Okay, you can get the lifetime missing support. We are also providing, and you also try to complete all of assignment which I already provide you. So simply complete this type of assignment, and further you can get also e-certificate, verifiable e-certificate. You can easily get from our website also. Okay, so let's go try to start for today's session. So let me share my screen. Okay, can you see my screen? Is it visible? Okay, thank you. So let's go. Okay, so basically today's session I try to discuss about that how we can easily make the change detection analysis using Google Earth Engine. Get different types of change detection such as land use, land cover, change detection, as well as how we can easily do for that normalize difference, vegetation, index change detection, and also how we can easily make the NDVI classification. Okay, and how we can extract the dense vegetation using thresholding technique also discuss. And also discuss about that class wise change detection, class wise land use, land cover change detection in one layer in Google Earth Engine. How we can easily do. We also discuss about that, and also calculate the transition area. Transition area, how we can easily calculate transition area, as well as discuss about that urban development or also urban growth monitoring or urban sprawl or also urban expansion. So these type of things, how we can easily do using Google Earth Engine. Also discuss, and also discuss about that hyperparameter turning or hyperparameter optimization for improving the accuracy of our machine learning model. So previous class I already discussed about that, how we can easily work with machine learning and how we can easily increase the accuracy. So this is the one kind of method, hyper parameter optimization, for improving the accuracy on your machine learning model. So we try to discuss about that all of things step by step. Then I hope we can easily get the idea how we can easily work. And also every class I also give some assignment. You also try to do this type of assignment. And further future, if you need any help regarding this type of assignment, you can easily join with me. Okay. So and for that, without Friday and Saturday, other day, without Friday and Saturday, before one day, simply knock me and take your schedule time. Okay, and then join with me, and further you can also discuss with your problem. Okay, so because we are also providing the lifetime teaching support regarding this online training program. If you face any problem, okay, any problem or any confusion, so basically when you want to work with your own study area, when you work with your own study area, you face some problem. Okay, so for this type of solution, you can get the lifetime teaching support regarding this online training program. Any problem when you face, you can easily get the solution. Just before one day, knock me and take your schedule time and then join. Without Friday and Saturday, you can get this type of support, no problem. But before one day, knock me and take your schedule time. Okay. And you also try to complete all of assignment. And when you complete the assignment, you also get that course certificate. And you can easily download the certificate from our website. You also, anyone can easily verify your certificate from this website and they can easily get. So you can simply click on the emails and you can easily download your certificate after submitting all of assignment. Okay. So let's go try to discuss our class. So basically in this case, I discuss about that mainly NDVI change detection, as well as also discuss about that land use land cover change detection, as well as we also discuss about that how we can easily increasing our accuracy, mainly land use land cover accuracy using hyperparameter optimization model, how we can apply. So first of all, we discuss about the change detection analysis. And previous class, I discussed about that how we can easily make the land use land cover mapping using machine learning in Google Earth Engine. So here I already create two decade land use land cover map. One is the land use land cover 2023, another is the 13. Okay, this is the map for 2013, and I classified vegetation, water body, build up, and sandy land. I classified. And this is the one map, land use land cover 2013, another for the 2023. Okay, so now between these two map, I already created, and I hope you also created this type of map because previous class I already discussed about this topic. So now I discuss about that how we can easily make the change detection between these two map, as well as we also calculate the transition area. Okay, as well as to make the change detection map using Google Earth Engine. So basically, if you check the imagery, so first of all, I simply take the imagery for the different two time. Suppose this is the image 2023, and this is the image for 2013. Okay, 2013, and also this is the image for 2023. Further, I simply take the training sample such as vegetation, water, sand, and build up from the image in 2013, as well as also open the image 2023 and also take the training sample vegetation, water, sand, and build up, and finally apply the random forest algorithm, and then we can create this type of map, land use land cover 2013 and 2023. Okay, as well as we already checked the accuracy, everything we already done. Here you can see, just let me show you that. So we find out that 98% accuracy, and also get the 96% accuracy, overall accuracy we find out for this two map 2023 and 2013. We already calculate this type of accuracy, as well as I already calculated the area, okay, land use land cover area for different time period. So now I try to discuss about that how we can easily make the change detection in Google Earth Engine. Okay, so let's go ahead and discuss about the change detection. So basically, change detection, we can do two types of change detection for land use land cover. One is the only for the single class change detection, another is the multi-class change detection. Suppose you want to work only for the urban, you want to find out that urban change area or urban change detection you want to create, or you want to create for urban expansion map. So this type of things are the single change detection, mainly single class. I want to work only for the specific class. It can be urban, it can be water body or vegetation, but single class. I want to work only for the single class. So I will show you that single class change detection as well as also multi-class change detection. Multi-class change detection means that at the same time, all of class we consider and make the change detection. And single class, we are just take a single class such as build up or urban or water or vegetation, any single class we take, and then we just make the classification. So let's go ahead and discuss about that. So first of all, single class change detection I want to create. Suppose I want to make the change detection between the year of 2013 to 2023. For that build up, how much build up area increase? Because we want to find out between these two time period. As well as I also want to create for suppose urban expansion map. Suppose this is the build up for year of 2013, and you can see 2023 lot of build up increase. Okay, so let's go try to discuss about that, how we can easily create the single class change detection of urban area for this two time period 2013 to 2023. So for doing this type of work, first of all, we need to create the single class map, only for the single class map. Suppose in this time, if you check the map, this map including total 4 classes, but I want to need only for the one class because I want to work for the single class. Suppose I want to work for the build up, so that's why I need to create a build up map, only build up map. Okay, when you work for the vegetation, then take only for the vegetation class. When you work for the build up, then take only for the build up class. So now how I can create the single class map? I just create the map of build up and other non build up. Suppose build up and non build up when I work. As well as suppose I want to work for the vegetation and non vegetation. Non vegetation means it can be anything, any class. Suppose water, non water. Just I create the binary class. Suppose I want to create for the build up and non build up. Okay, suppose in 2023 and 2013, these two map, land use land cover map, but now I want to need only for the build up map in 2023, as well also land use land cover 2013. Just I create the single class map of urban or build up. So for doing these things, first of all, you have to check the variable name. Okay, so land use land cover 2013 and land use land cover 2023, these two map is already stored in a variable. So you find out what's the variable name. Just find out the variable name. In this code, if I check my variable name, so you can simply go to the app, you can easily get this variable name. Basically, which variable is stored this map. These two map is stored land use land cover 2023 and 2013. So we can easily get it in the map.addLayer function. You can see, okay, this one. You can see. So I create the classified and also classified one. So basically, this classified, if you check the layer name, it's the land use land cover 2013. So land use land cover 2013. This map is stored in this variable name classified. And I take the another 2023. This map is stored the classified one. Okay, we can put any variable name as a. So just find out the which variable is stored the land use land cover map 2013 to 2023, because when I make the change detection, I need this two variable, because this variable is stored the land use land cover map for 2 decades 2013 and 2023. So let's go classified and classified one. This is my variable name, and this variable is stored the land use land cover map for 2 decades. So now I want to make the urban map, suppose 2023. Okay, just I create the urban map in year of 2023. So for that, just call the map variable name. So you can see, just I take a variable. Suppose I put the variable name is that build up area 2023. You can put any name as a variable. I put the variable name build up area 2023, and I call the classified one, because this classified one is stored the map in year of 2023. So just I call it and then put the dot eq. Eq means equal, and put here the value. So this value I get from here. You can see this is the 0, then 1, then 2, and this is the 3. You can see the value. This value is the 3. 3 means the build up. In this case, I want to create the single class map of build up. So that's why I simply put here equal to 3. Okay. So I take a variable and then call my variable, which variable is stored the map in year of 2023. In this code, I add the variable name classified one, and I then set equal to 3. 3 is the level value. Okay, 3. 3 for build up. So just I put the 3. So now this variable is stored a binary class. It is stored only for the build up and non build up. Okay, this variable is stored build up and non build up. So let's go try to display it. So for that, I just add a new layer, just put here map.add function and call it. And I put here the 0 and 1. 0 means that there is no build up, mainly non build up. And 1 means that build up. So I have to show no build up, show as a gray color. Gray color means that there is no build up, and red color means that build up is available. Okay. So we try to add the layer, and I put the layer name is the Urban 2023. We just create a binary class, mainly build up and non build up. Build up show as a red color, and non build up show as a gray color. You can put any color. So now let's check if I run the code, what happened. Okay. So now you can see, now we find out the gray color and red color. Red color indicating the build up area. Okay. And gray color indicating about the non build up area. Mainly there is no build up. So now we find out that single class map of build up. Suppose you want to create the map only for the, suppose sand land. You want to find out only for the sand land. So now you have to check what's the value of sand land. It's a 2. So just you can simply change the value from here. Suppose I put here the equal to 2 because 2 is the sand length. And I want to show the sand length as a, suppose I want to show some sand length as a yellow color. Yellow. So now it creates the map of sand land in year of 2023. So run the code. So now you can see we can got this type of map. So here this yellow color indicating about the sand land, and gray color non-sand land. Okay, so it can be other class including, and basically this type of yellow color show as a sandy land or barren land, and this type of gray color it's indicating about the other class. Suppose I want to create for vegetation, so simply check the vegetation value is the 0. You just put here that equal to 0, and I want to show the vegetation as a green color. So just put here that green color. You can put any color. I put the green. So now in year of 2023, it show the vegetation, only vegetation and non-vegetation area. So you can see find out this type of vegetated area. Basically this type of green color indicating about the vegetation area in year of 2023. Okay, so we can find out this type of green pixel or green color indicating about that vegetation, and gray color indicating the non-vegetation. So this is the process to create the single class map. Suppose you need only for the vegetation area map, sometime you need only for the build up area map or water body map. Just simply put the value. Okay. So now I want to work for build up. So for that I put the build up value. You can check the build up value is that 3. So just I put here the 3. and I want to display the build up color as a red. So just put here the red and run the code. So now it creates another new layer only for the build up in year of 2023. We find out this type of map. So now in this map, I want to calculate how much build up area is available in year of 2023. I want to calculate it. Calculate the area. Okay. So calculating this area, just I take a variable, suppose urban area. You can put any name as a variable and call this variable build up area 2023 and then multiply with this function. So basically this function provide you the result in square meter unit. We find out. Okay. So now just I call this build up area 2023, then multiply with this function and further apply the reduce region function to calculate the total area. So for that, just I use this code. Here you can see just take a variable and then call this variable urban area. And in this variable, just apply the reduce region function and put all of argument. I want to calculate the total area. So put here e.reducer.sum and geometry mainly shape file variable name. Scale mainly 30 meter for land set. And max pixel, I put the 1e13 as a big region. And further, if I just print, so now it computed how much build up area is available in year of 2023. Just run the code. We find out that this property, you can see this result show as a square meter unit. Suppose I want to convert into a square kilometer. Okay. So for conversion, this unit, so basically it's a number. So for that we have to use the function e.number. Okay, just I take a variable. Suppose our urban area in 2023 square kilometer. So it's a number. Okay, it's a number. So I have to use the function e.number, and this number store it in a variable. This variable name urban area 2023. So just I paste here, and you can see it keyword get from classification. Okay, so for that just use here the get function and put here the classification, and further divided 1 is 6. Then it convert the unit as a square kilometer. So I can explain. So it's a number. So when you define any number in Earth Engine platform, we have to use the function ee.number. And this number is stored in a variable. This variable, this is the variable name. And this number get from classification, because classification is the key word and this is the key value. So for that, just use that the get function and call this classification. Okay, classification, and finally divided 1 is 6. Then it convert a square meter to square kilometer. So just we print the variable, run the code. So now it's computing how much area is available in year of 2023. And I find out there's a 824.99 square kilometer. Okay, so this is the result from this map. From this map, we calculated how much build-up area is available in year of 2023. This process you can also apply for any other class, any other single class. Okay, so now I also need to calculate the same process we also apply in year of 2013, because I already make the map 2013. Okay, I want to calculate the how much build up area is available in year of 2013, as well as also make the map in 2013 build up map. Okay, so same procedure you apply. So first of all, I need to call the variable name, which variable stored the land use land cover map in year of 2013. This classified, this variable stored the map in year of 2013, and then I set equal to 3, because you can see these things. You can see basically it's the same. You can see it's also 3. 2023 is also 3, as well. If you check, it also 3. Okay? We take the two time training sample. Okay, one time for in year of 2013, another time year of 2023, and then make the classification. But value is the same, so just I call the value to 3. This is the value 3 for build up, and I want to display the map. I want to display the map. So now if I run the code, so it creates the build up map in year of 2013. So it created another new layer, urban 2013 created. So we find out this is the map. This is the urban map in year of 2013, and this is the urban map 2023. Okay, this is the 2023 condition of urban. And this is the map year of 2013. Okay, lot of build up increased in year of 2023. So now we also try to calculate the area, how much build up area in year of 2013 we calculate. Just apply the same process. Just I take a variable, suppose urban area, and call the build up area 2013 and multiply with this function. Then apply the same process. Just calculate the total area. Using reduced result function, we apply in here. And to calculate, is convert the unit square kilometer. So now if I run the code, just run the code. So now I display the result, how much build up in year of 2013. We find out that 586.44, okay, square kilometer area in year of 2013. Okay, and 2023 find out that 824.99. So we find out that almost 238.55. Okay, 238.855 square kilometer area of urban increased between these two time periods. Just simply subtract this value and this value. Then we find out that how much build up area increased between these two time period. We find out that 238.55 square kilometer build up area increased between these two time period, 2013 to 2023. Okay. So now I want to make the change detection map. Change detection, and also make the urban expansion map. Suppose I want to create the urban expansion map. Or if I show some example, suppose just I show you that. Suppose just open it. So there you can see we just create the 3 years, mainly 2000, and 2020. Just create the single class of urban mainly build up, and then we try to display this type of pre-decade only for the build up. Okay, as well as it also called that urban sprawl. Suppose you want to display the urban for 2000, so this is the blue color indicating the urban in 2000, yellow color indicating the urban 2010, and further red color indicating about the urban in year of 2020 for this map. So this type of things you can also create it. So it just you can also create Google Earth Engine, or if you want, you can see the easily download this type of layer as a GOT file format. Simply download the GOT file format, and further you can easily make the map in ArcMap or QGIS software. But in this case, I want to create the urban spiral mapping in Google Earth Engine. Suppose in urban 2013, I want to show as well as also show in urban 2023 at the same time for different color. So anyone can easily get the idea was which area for 2013 and which area for 2023. We can easily find out. So let's go so far that how I can create the urban spiral mapping in Google Earth Engine. But you can also do it also ArcMap software easily and also create this type of map after downloading the this type of GOT file format. Simply download it and make the map this type of map you can easily create. So now I want to create this type of map using Google Earth Engine. So for that, we need to create the mainly just remove the binary class and take the single class. Single class means that in this map it show the gray color and red color. Okay, gray mainly non-build up and red mainly build up. So now I just keep only for the build up and then remove this gray color. Okay, remove the gray color from both of map 2013 and 2023. Just remove the gray color. Just remove the gray color, and then I set the different color. Suppose in urban 2013 I show the one color, and to the 2023 show the another color. Okay, as well as also remove this type of background, mainly gray color background. I just remove, and it work as the urban spiral mapping also. So now how I can remove and create the only for the build up, two time period 2013 and 2023. So now for that, just we try to add the code. Okay. So after selecting equal to 3, okay, first I do for the 2023. So after equal to 3, then use a new function. This function called the self max function. This self max function mainly max with only for the self, and also remove the gray color and create for the single class, not 0 and 1. It create only for the urban. So for that, just remove the mean and max value. It's not need, just remove. And I put the 2000, just also remove the color. It's not need. Okay. So now it just only show the build up. It's not showing the non-build up, just showing only for the build up and show as a red color. These same things I can also apply for the year of 2013. So for that same process, just use that function, self max function, and then just remove the mean and max. It not need. And I want to display this build up area in 2013, another color. Suppose I want to show as a which color. I put suppose yellow color. Okay. So we put the yellow and also put here that red. Yellow mainly show the build up 2013, and we already remove the background. So if I run the code and check what happened. Now you can see here, we find out that this type of yellow color, it's indicating the build up in year of 2013, and also a sporal in the periphery region. You find out that this type of red color it's set up. This type of build up is set up in year of 2023. Meaning newly set up build up. This type of. Okay. If you want, you can also add the more decade. Suppose 2000, 2005, 2015, 2010, or 2020. Okay. So you can easily add the same process and also display the different types of color and then easily create the urban sprawl mapping for the different time. That was 2000, 2010, 2020. Look like. And if you want, it's also possible. You can see now we can easily find out for this study area. We can easily find out this type of yellow color is the build up in year of 2013. And this type of red color, we find out that build up in year of 2023. We find out this type of things. So we can also create this type of way and also create the urban spiral mapping in Google Earth Engine. But it also more better. You can simply download the GeoTIFF file format and further you can easily make this type of map for your research paper or presentation using ArcMap software or QGIS software. So this is the process to work with for urban spiral mapping also in Google Earth Engine. So in this case, I just work only for the 2 decade. So that's why it created the 2 decade for different 2 color. Okay. So when you add the other decade also, just apply the same process. Okay. So now we find out that this type of area for different 2 time period, we find out that 586 in year of 2013 and 2023 824. So almost 238.55 square kilometer area increased. Okay. So now I want to check for the change detection for the urban area. Okay. Suppose if you check the this map, here you can see it this type of region. If you also open the 2030, you can see the yellow color. So this type of yellow color, it was urban in 2013. And also open the 2023, we also find out also this is the urban. Okay. So it was urban in 2013 and this place also in urban in 2023. So basically there is no change. Okay, there is no change because if you can check the both of map, we find out that this type of yellow color, it was urban. Okay, and in 2023 it also show the urban. Okay, so for this type of place there is no change. Okay, mainly if you just open this map, then you can easily get it the newly set up. So basically this type of red color, this type of red color, okay, this type of red color after opening the layer in 2013, which red color is available, this red color show the newly set up urban area in year of 2023. And this newly set up urban area, how much area increase? This is a subtraction between the 2824 and 586. We find out the 238.55. So this area now, this type of red color, only red color, it creates the newly set up urban area in 2023. And how much area? This area is a 238.55 square kilometer. So these things you can also get the more better when I just simply subtract. Just simply subtract before class and after class. Okay. Just simply subtract these 2 things. Just I want to display that suppose changed map, urban changed map. And I call the build up area 2023 and I'll subtract with build up area 2013. Okay. Then we try to show the result. Just at the run. In this case, you can see I also apply the self max function. So that's why it not create the binary class. It just create the single class of urban change area. Only show the urban change area. Suppose this type of red color, there was no urban. But in 2023, it create this new urban. So try to check it what happened if I run the code. Okay, so let me add the binary class. And the changed and unchanged area. Okay. Just put here the mean 0 and max 1. Where there is no change, suppose show as a white color. And where is changed, mainly newly set up urban area, show as a suppose red color. Okay. So you can see we find out that this type of white color, it means that unchanged urban area. And this type of red color, if I just only open this layer, then you also get, suppose you can see here, we find out that this type of color indicating about that newly set up urban area in year of 2023. Okay. And this type of white color indicating about that unchanged urban area. There is no changed, only unchanged. And this type of red color indicating about that it's a changed urban area, mainly newly set up urban area. And how much area? Just simply subtract these two value. We find out that 238.55 square kilometer. And if you want, you can also download the urban change map also from here. Okay. As well as you can also create this type of urban sprawl mapping and also display this type of things, as well as urban expansion. So you also download this type of GeoTIFF file format, and further you can also work with that. So basically, this is the process to work with single class. So you can apply for this type of method for vegetation, water, sand, or any other classes. Just apply the same process and also work for the single change detection. Also calculate the area. So now any question about that, you can ask me please. Any question or any confusion, please. Okay, if there is no question, you also try to do further for your own study area. Further space any problem, then also ask me for any time, no problem. So this is the process to work with single class change detection, as well also make the urban expansion or urban sprawl. So this type of map we can easily create also Google Earth Engine. So now I talk about that how we can easily make that. It also calculate the urban change area also calculated. Suppose how much area we can find out. How much new urban setup area we can also get it. Suppose for that just same process. So urban change area, then I call it, and then we just multiply and calculate the total area. Urban change total area we calculate. So just uncomment these things. And further just convert square kilometer unit. Now another put. So now we find out that how much urban changed between these two time period. We also need to print this square kilometer area unit. Okay, show the zero. Why? Check. Okay, I think for that calculating this urban change area, when you calculate, then we are not using the self mask function. We are just create the binary class and then calculate it. Okay, so let me calculate without creating the binary class. So put at that mean 0, both of I put at the max, suppose 1. Okay. And build up and non build up. 0 here or non build up. So I'm going to show as a gray color for the non build up, and build up show as a red color. Okay. And also do for the same process for 2023. Just remove the self marks. Self marks is neat only for the when you show the urban spiral. You just remove the background, then take only for this build up class. No, and also remove the non build up. Okay. So just put here the mean. I put the 0 for non build up and max for build up, and add the color plated, and I add the for gray color, it means that there is no build up. Red means that build up in year of 2023. So now check it. So now you can get the accurate result. How much area changed the urban? Just simply we find out the 228. Okay, or it will be 238. So I think it show okay. So we have to check the scale. This scale is the 100. Okay, we have to put the scale 30 meter for that. Now try to check. So it will be 238. So now let me run the code again. And now if you check this tab, you can see here, we can get this type of map, and it show the urban changed map. Basically this type of red color show as a changed area in urban. And this type of white color, it means that there is no change. It's totally unchanged area between these two time period, 2013 to 2023. Okay, well, only for the single class change detection. Okay. Okay, so it showed, okay, so it's a big study area. So it's another limitation. It show the user memory limit exist. Okay, because there is a lot of pixel. For that, I just try to keep it suppose 50 meter. Just I increase the scale value and then calculate the area. It's still same. So I put the 100. So now it worked. We find out that 228. Okay, we find out that 228, and it show the result 238, because in this case, when I put the scale 30 meter, then it show the user memory limit exist. Okay, so that's why you find out this type of 228, 10 meter less. But when you subtract this two value, then you find out the result 238. Okay, and so this is the not big issue. And sometimes when you work for the big study, then you face this type of problem. So then you try to calculate the area. If you want, you can also calculate the area in ArcMap or QGIS software. It's also possible when you face this type of user memory limit exists. Or if you want, you can simply increasing the scale value. When you increase the scale value, then it consider the pixel size 100 meter and calculate the area. So that's why in this case, I already calculated the two things, 280, 824. I use the 30 meter and also use it for 30 meter. But when I calculate the change area, I put the 100 meter. So that's why it show the different result. Okay. So if you want to keep the same scale value, suppose in this case, if you just put in for this calculated area, just put here the 100 meter and also put here the 100 meter. Okay, and also put at the 100 meter, then you also get the similar value also. But our landscape basically scale, it's different on the resolution on our satellite imagery. So our satellite image resolution is that 30 meter. So that's why you put the 30 meter. Okay, then you also get the more better accuracy when you put the 30 meter, because my resolution or pixel size is 30 meter. So we try to keep the 30 meter both of places. And further, for this calculating this area, basically mainly this to 824 and 586, we just keep the same scale 30 meter. But when you put the 100 meter, you get this type of result. But this value will be 238 meter. Okay, when you keep the 30 meter and calculate, then we put the value 238 meter square kilometer area. Okay, so this is the one kind of limitation for the Google Earth Engine. User memory limit exists. So then it also better. You simply export this map, simply export, and further use the ArcMap or QGIS software to calculate the pixel area. Then you also get that more better. Otherwise, if you just increase the scale value, then you can get this type of problem. It show the 10 meter less, 10 meter less. It show the 228, but it will be 238. Okay. So now after calculating these things, we this is the process. We calculate the square kilometer area calculated. So now this is the process for that single class change detection. And now we talk about the multiple class change detection at the same time. In this case, we are not considered for the single class. We are considered all of classes at the same time. So let's go discuss about the multiple class change detection, how we can really do. And at the same time, we also discuss about transition, mainly water to water, water to vegetation, or build up to water or water to this type of things, transition, mainly change transition area for one class to another class, how we can easily calculate for the multiple class change detection. So let's go try to explain about that for